Hello everyone and welcome to our next lesson in our unit on area. Last week we talked about basic area and this week we're going to talk about multi-step area. Multi-step area is a little bit more tricky. It brings back in some concepts that we've done previously in geometry. So we're going to review a couple of things real quick at the top here. For the first question, we need to go back through Pythagorean theorem. So we have a right triangle listed here on number 1 with side lengths with legs of 7 centimeters and 15 centimeters, and we're trying to find the hypotenuse, which is x. So we're going to have to plug 7 and 15 into Pythagorean theorem for our a and our b values to solve for c, the hypotenuse, which is x. So in order to do that, I've already got the equation set up here, a squared plus b squared equals c squared. So let's plug in 7 for a, and let's plug in 15 for b. We'll plug in x for c since that's our hypotenuse. And now we're simply going to solve from here. 7 squared is 49. We get 15 squared is 225. So we're going to add 49 plus 225 together, and we get 274. So in order to solve for x, we need to take the square root of both sides. So x is going to equal the square root of 274. If we punch that in our calculator, we'll get approximately 16.55. Okay, so there was a little review over Pythagorean theorem. Let's move over here to number 2 and let's talk about a review over how to do trigonometry. So in our problem here we have another right triangle. This time we're trying to find the side length x, but we only have one of the other legs as 14 and we do not know what the hypotenuse is. But we do see that we have the angle given to us as 32 degrees. To use trigonometry, you have to know the angle, another one other than the right angle, and you have to at least know one of the side lengths. If you know that, you can figure out all the other sides. Alright, so going back through our trigonometry, I've written it out, SOHCAHTOA up here at the top, where we have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you remember our steps on how to solve these, we're going to circle the angle that we're going to use, which in this case is 32 degrees. We're going to draw an arrow to the opposite side and label that side that has the x as the opposite. So I'm just going to put OPP. We know that the side across from the right angle is always the hypotenuse. And that leaves 14 over here will be the adjacent side, the one that is next to the right angle. After we have done that, we need to figure out which of those two sides we can use. Well, you see here that we have 14 for adjacent, we have x for opposite. The hypotenuse doesn't have any information on it, so I'm just going to cross that off because we're not going to use that. Next, I need to figure out which of these three trig functions we're going to use. I have opposite and adjacent, so I look through sine, cosine, and tangent and figure out which one has opposite and adjacent. Right here, tangent has opposite and adjacent, so I know that I'm going to use tangent. So now let's set up our equation. We'll say that the tangent of the angle, which in this case is 32 degrees, is going to be equal to the opposite side over the adjacent side. So that's x over 14. The next thing we have to do is ask ourselves, is the variable in the numerator or the denominator? If it's in the denominator, we divide. If it's in the numerator, we multiply. This one is in the numerator, so our shortcut here is that we have to multiply the other two things together. So x is going to equal 14 times the tangent of 32. From here, we can just plug this into our calculators. We need to make sure that our calculators are in the correct mode. They need to be in degrees and not in radians, so remember to check your mode. Punch that in the calculator, and you'll get approximately 8.75 for x. Now that we've reviewed Pythagorean theorem and trigonometry, we can move on to the rest of our example problems. Here in the middle of your page, there's a box that says ask yourself these questions. So when we solve multi-step area problems, we need to ask ourselves these questions. What area formula will I use? What measurements do I need to find to use the formula? And how can I get that measurement? So our first example here is a rectangle. So our first question is, what area formula do I use? Well, the area for a rectangle is base times height. So clearly, what measurements do I need to calculate to use this formula? I need to know the base, and I need to know the height. You'll notice that in the rectangle, there's a diagonal that is 8 inches long. This is a 30, 60, 90 right triangle. You could use your 30, 60, 90 shortcuts here if you remember them, or you could use trigonometry how we did on example number 2 just a second ago. I'm going to use trig on both of these. If you remember the 30, 60, 90 shortcuts, feel free to use those as well. So the first thing I need to do is figure out how can I find the base. So let's look at our triangles here that have been created by that diagonal. I know that the height is over here on the right. I know that the base is down here at the bottom. These are the two things that I need to find. So let's start with trying to solve for the base here. I'm going to circle my angle here, which is 30 degrees, draw an arrow to my opposite side, label it OPP. I know that across from the right angle is the hypotenuse, so 8 is going to be my hypotenuse. And in this case, B would be my adjacent. In order to figure out what the base is, I need to figure out what would I use. I'd use the base that is the adjacent side, and I'd use the hypotenuse of 8. So I'm going to use adjacent and hypotenuse. So I go back and look which of the 3 trig functions has adjacent and hypotenuse. It would be cosine in this case. So when I write my equation here, I would say the cosine of my angle, which is 30 degrees, equals the adjacent side, which is B, over the hypotenuse, which is 8. Alright, once again, just like in example 2, our variable is in the numerator, so we're going to multiply these two things together. So B is going to equal, I'm going to keep coming out here to the right, B is going to equal 8 times the cosine of 30. And once again, I'll just plug that into my calculator, and we'll get that the base equals approximately 6.93. Okay, now that we know the base, we need to find the height. Well, I've still got my same right triangle. I've already labeled it adjacent, hypotenuse, and opposite. So now the height is the opposite side. The one that has the number is the hypotenuse. So I know that I'm going to use opposite and hypotenuse, which if we do that, we'll use sine this time around. So this time I would say the sine of angle 30 equals the height divided by 8. Okay, once again, variable's still in the numerator here, so my height, is going to equal 8 times the sine of 30. Plug those in your calculator, you'll get the height equals approximately 4. Now, the last step on this is to solve the problem. We've found our height, we've found our base, we can plug those in the area formula for our rectangle. So once again, area equals base times height, we said. So my area is going to equal 6.93 times 4. So my final area, when I punch that in my calculator, my area of that rectangle is going to be 27.72. And that's going to be in inches squared. Okay, let's move on to question number 2. In question number 2, they want me to find the area of the kite. First off, we need to figure out what area formula we'll use. The area formula for a kite is A equals 1/2 diagonal 1, which is D1, times diagonal 2, which is D2. So remember, the diagonal is the complete length from one vertex to another. There's 2 diagonals in the kite. So the next thing we need to do is figure out what are the 2 measurements that I need to calculate to figure out this formula. Well, clearly I need the 2 diagonals. I need D1 and I need D2. The only piece that I have right now given to me in the problem is there's a little half length there on the left that says 20 centimeters. That's part of a diagonal, but that's not the whole diagonal. So I need to ask myself, how can I get these other measurements? Well, you'll notice that all these, when the diagonals of a kite intersect to form right angles. Okay, so this has been broken up into 4 right triangles. Okay, that should give me a hint that we can use trig or we can use Pythagorean theorem. In this case, we're going to use Pythagorean theorem, or to make it even easier, Pythagorean triples on some of these. All right, so if I wanted to figure out the rest of that length of the diagonal here, that's 20. So I want to figure out from the middle here. I'm going to highlight it. Let me change colors. So I want to figure out this piece right here in red, because if I figure out that piece, I can add 20 to it to get that first diagonal, correct? All right, so let me back up here just one second, because actually we need to do this triangle that's on the bottom left first. Okay, you guys see this triangle right here? Well, I know 2 pieces of that triangle. I know one side is 20, and I know that the hypotenuse is 25. I should be able to find that missing side length by using Pythagorean theorem. All right, so let's just call it x for right now, for the missing side. So let me punch that in my Pythagorean theorem here. I would say x squared plus 20 squared equals 25 squared. And then you would go through your Pythagorean theorem. You could also use Pythagorean triples here if you wanted to. If you look at the triples chart that's included in your notes today, you'll notice that the triple says 15, 20, 25. So that's going to tell me that x is going to be 15 in this case. Okay, so we figured out that this piece is 15. If you remember properties of kites, the longer diagonals bisects the shorter one in this picture. So if this piece is 15, that means this piece is also 15, meaning that the whole diagonal would be 30. So we're going to say that D1 is 30. All right, now that we know that, we can do another round of Pythagorean theorem or Pythagorean triples to figure out that missing piece that I was talking about a minute ago that I jumped ahead of myself on. I'll highlight that in blue here. So now I want to figure out this piece right here. Okay, I'm going to use this triangle at the top. So I know that one piece is 15, one leg is 15, and the diagonal is 39. So we could use Pythagorean theorem once again to find that missing piece. So I'd say x squared plus 15 squared equals 39 squared. Or once again, you can use your Pythagorean triples chart, and if you do that, you would figure out that the missing piece is, the pattern is 15, 36, 39. So 36 is the missing piece here. Okay. So right here, this piece is 36. Okay, so my D2 in this case would be that 36, and we'd add that piece that's 20 onto it. 36 plus 20 is 56. Okay, so now I have my 2 diagonals. You'll see right here I got the D1 was 30,